Everyone, and thank you for joining us for our webinar on reducing data transmission costs in the oil well life cycle. I'm Liz Wilson. I'm the Marketing Director of Ground Control. I'm joined by Ben Travers, who's our Product Director. And Ground Control, if you're not familiar with us, is a company based in the US and UK that specializes in satellite and cellular connectivity, chiefly for M2M and IoT applications. We've got a number of customers in the oil and gas space, and we've worked really closely with them to optimize their costs. Fundamentally, it's the output of those exercises that we're going to run through today. Today, we're going to look at 5 ways to lower the costs of extracting data from your well sites. We're going to look at reporting by exception, accurate device pointing, network monitoring software, remote activation and deactivation of devices, and edge computing. And we've put some bonus content in here about selecting the right satellite device. So some of these things you might be very familiar with and you may already do. Pretty confident you won't be doing all of them. So by all means, fast forward to the bits that are most pertinent to you. But we're really confident that there's going to be something in here that will be of great value to you. So this great quote from the analysts at McKinsey is worth starting with. It points out that an advanced connectivity to optimize drilling and production throughput and improve maintenance and field operations could add up to $250 billion of value to the industry's upstream operations by 2030. So I think it's worth setting out this conversation in that context here. So reporting by exception, it essentially points towards only sending the data that's really important to the operation of the oil well. And we often do see oil and gas companies sending sensor data at periodic intervals. That could be 15 minutes, it could be 3 hours. But in every single one of those scenarios, we're seeing that a lot of the data they're sending isn't used or isn't useful. And so I'm just going to pass over to Ben to talk a little bit more about reporting by exception.
So as Liz says, this is very much about only sending the data that's really important to the day-to-day operation of the oil well. So a lot of data that's generated is data that's within normal parameters that are set with the monitoring devices that you're looking at. What it means is that if you only set the data to be sent that goes outside of that normal operating parameters, you become far more efficient in both the data that's being sent over the network. So there's a lot less data actually being sent, but also the data that's coming into your back office shows that it's only data that need to be acted upon, sort of thing. So you become far more efficient in the way you're seeing the data coming through to the back office. So the whole, and this essentially is an early stage of edge computing. So where you're doing some data processing, at least on the edge, before it actually gets sent over the network into your back office. So in effect, it's building far more efficiency, both in the amount of data that's being transferred, but also the events that are being transferred back into your systems for which you can act upon.
Thanks, Ben. And the next point we're making here is about pointing your device effectively. And we know, obviously, in the oil and gas industry, it's very, very common to use a BGAN device. And these point at what we call geostationary satellites. And a poorly pointed terminal can drop IP packets and can require information to be retransmitted, which obviously adds to your cost. And it sounds really obvious, but we do see a substantial number of companies not angling their satellites at the optimal direction to get the best connection with the satellite in question.
There are a number of tools here. So there are a number of things here that you can use to address this properly. Firstly, there are a number of tools available to help point your BGAN terminal properly. So I think it's worthwhile spending and investing in making sure that your terminals, your satellite dishes are actually pointed in the right place to get optimum coverage and be far more efficient in the way you're transferring data. Secondly, actually, it's worthwhile looking at the range of options available in terms of satellite connectivity to make this a little bit easier. So we move on a little bit into looking at the options available to you. So to talk a little bit about geostationary satellites versus low Earth orbit. Geostationary satellites, as the name indicates, have a stationary satellite to which your satellite dish is pointed towards. So you've got to be really accurate in the way that that dish is pointed. to actually get the most efficiency out of your data communication. And services like Inmarsat operate in exactly this way. A small number of satellites, geostationary, to which you point your dish, your antenna, to get data coverage. If you compare that to low Earth orbit, many more satellites deployed. It therefore at a lower Earth orbit, essentially, which makes it a lot easier for the antenna to be pointed. Essentially, in fact, it's very often auto pointing or omnidirectional antennas that make it a lot easier to actually get a satellite connection, and therefore you don't actually need to go through the process of pointing that satellite dish to get optimum coverage, because there are a number of satellites to which that antenna can connect to. Those sorts of services are operated by people like Iridium, and they're freely available and very easy to be able to sort of connect your terminal to, and therefore your efficiency in sort of data communication is managed without needing to actually physically point the satellite dish, the fast satellite antenna.
So I think the summary of that point is 3 choices. Make sure the satellite is pointed. That your terminal is pointed appropriately to the satellite. Use an auto pointing device, of which there are many Inmarsat services available that offer auto pointing, or use a low Earth orbit device that doesn't need to be pointed because it's going to hit one of these rotating satellites by some mechanism. So there's no need to make sure it's pointing in the right direction. The third point on our list is to use network monitoring software. This is something Ben's far more familiar with than I am, so straight over to Ben.
So the point here is ultimately there are plenty of tools available to monitor the traffic going over the network. So I think it's being aware of how your terminals are connecting and sending data. There are, as I said, there are plenty of tools available. Ground Control's Cloud Loop platform offers this as standard. It gives you a good idea of data usage. And if you become aware of that and start to actively manage that, you start to get a view of how much traffic is actually being sent, whether that's right or not, whether there are any areas of concern in terms of too much data or not enough data being sent. So you get a good view of how much and how you can ultimately optimize the amount of data traffic that's being sent. It also points towards the service plans that you're using. So if you're consistently going over your planned rate, it could often be more economically efficient to upgrade your service plan to something that is meeting your data needs, and therefore you're not paying overage rates at a higher rate generally, sort of thing. So it's worthwhile being very well aware of the amount of traffic that your data, your services are transferring, and making sure that you're using the right service and right service plan accordingly.
And certainly something like Cloud Loop shows you sort of down to specifically which terminals are overusing data, so you can investigate and make necessary changes to those terminals to help lower your costs.
Absolutely, and it gives you that data at that terminal level, at that subscription level, to understand how many, if you've got a rogue terminal out there for whatever reason, actually you get a view of that being out of sync with where it should be, sort of thing. So it's worth being very well aware.
I do love the term rogue terminal. It's tickled me. So the fourth point we're making is around activating and deactivating devices remotely. And the simple question is, do you need all of your satellite terminals active at all of the time? And it's almost certain that you don't, that there will be devices out in the field that are not useful to you right now. But equally, sending people out there to physically deactivate them is cost prohibitive. But if you can do this remotely, then you've got the key to unlocking more cost savings.
And this sits nicely alongside the active monitoring of the traffic on your devices. So this is about being proactively managing your device, the devices that are deployed, making sure you're aware of the amount of data they're transferring, and then actually indeed working out whether they need to be connected all the time. So the tools available in Cloud Loop do allow you to do exactly that. You can suspend a device for a period of time when it's not needed, when the usage gives you more cost efficiency in the way you're more proactively managing your device portfolio. So it's be very, very, the point ultimately is make sure you are on top of the devices that you have deployed. You've got the tools to be able to do that. And that can ultimately save you quite a lot of money and make your whole service more efficient by doing so.
The next point is edge computing, which is something Ben is personally quite passionate about. So it's a relatively new phrase. It's creating a lot of buzz in many industries, including oil and gas. And basically, as my understanding is, it allows you to process your data where the data is being generated. So there's less requirement to send all of your data into the cloud. You can just send what you need. But Ben, being the expert, I'll allow him to give you a much more detailed overview.
And this follows on a little bit from managed by exception. So we've heard a lot about cloud computing, and there's a lot of industry noise about taking your data and doing your big data processing within the cloud itself. When you put that into the context of a relatively constrained, relatively expensive data transport mechanism, sending all your data, every bit of your data to the cloud starts to get very, very expensive. So that points towards a trend towards edge computing. So if you look at that you can look at that in two ways. One is making sure you're taking data from your range of devices and doing something with it before you send it over the data network, over the satellite network. So if you're optimizing the amount of data it's sent, and it's very similar to sort of communication or management by exception. What you can do is you optimizing the types of data that's being sent, and the process is being done locally by a processing unit locally. You'll see some sort of monitoring devices will have this inbuilt already. But in many cases where you've got legacy monitoring equipment, it won't have that capability. So you're just going to be sending the raw data. So in having a terminal that sits in the middle that helps to aggregate that data, optimize it, process it before it's sent, will help to sort of optimize the amount that's being sent itself. You can then look at the efficiency or the way in which that data is being sent over the network. So your network protocols. So there's systems like or protocols like MQTT, and specific to the oil and gas industry, Ignition, which has an MQTT as a basis, which optimizes the way in which the data is being transferred over the network to make it far more efficient. So it's ultimately you're sending less data as a result of that. It's far more efficient from a cost perspective, and it's being sent to a cloud back end that ultimately is designed to be able to process that data efficiently, as it were. So end to end, your whole process becomes far more efficient, far less costly by actually doing some work before you send the data to the cloud.
And then for our bonus section, we wanted to make a final point about flagging that satellite connectivity has massively diversified in the last few years. Ultimately, not all satellite connectivity is the same. And there's different services and devices for different applications that will unquestionably be more cost effective than opting for a one-size-fits-all approach. So if we have a quick look at the oil well life cycle, there's a requirement for data communications at every stage, but they're not identical. And if we look at exploration, where we're looking at geoseismic data, the better with which to make decisions on whether to drill, the high throughput requirements here lend themselves to a VSAT, which is your traditional round satellite dish that can manage high volumes of data in close to real time. But one step on, drilling has much smaller data requirements. And for something like this, you may well be better served by the Iridium short burst data service. Ben, would you add anything?
Yeah, I think, the point here ultimately is that there's a range of services and devices available that can be designed to be fit for the individual purpose that they're required. So there is not a one size fits all approach to connectivity. And I think the range of services and devices that are available in the market today can really help to be tailored towards the specific need that is there. And it talks a little bit towards, actually, I'm going to give you a bit of an example of the sort of services that are available to sort of give you an idea of the options that you have available. So Liz, if you'd like to move on to the next slide for me, please. Essentially, if you look at this in terms of the amount of data and the frequency of data that you are looking, or your application it needs to send. At the very low end of this, the messaging-based protocols that measure data volume in bytes, essentially, that come from services like Iridium SBD and Inmarsat IDP, really are very efficient. They're very cheap. They're very, very cost efficient to be able to integrate and operate. But they are very, very good for those sending heartbeats, small amounts of data on a very regular basis. As you start to move towards more mission critical, right? So having something that is always online, a constant IP connection to the network, but doesn't necessarily need to send large amounts of data. You've got services that, and these are services that are measured in kilobytes, and perhaps low-end megabytes. Big and end-to-end Certus 100 as services, and the devices that fit alongside those for those sort of IoT M2M style use cases are really, really valuable there. They really fit quite nicely there. So what you've got is a step up from a more basic messaging-based protocol to something that is constantly connected, but only sending smaller amounts of data. As you move towards the more mission critical, the more high data throughput requirements that you have, and you can move towards the higher end of BGAN and the higher end of Certus, but also into VSAT and TSAT, for truly sort of reliable mission critical data volume measured in megabytes. Those sorts of services exist. So the point around this ultimately is that it isn't one size fits all. There is a solution for each different use case, but what's the point is there's no point in putting a VSAT or TSAT service for everything, because it isn't cost efficient in that way. Some of the services in the life cycle will only require a messaging based protocol that checks in on a regular basis, and that's sufficient to be able to deliver the needs you need from that level of the life cycle in oil wells.
One thing we're conscious of, and certainly not wanting to make this into a product pitch, but Iridium Certus 100 is a relatively new satellite connectivity protocol, and there are very few devices out there that offer this service. It sits somewhere slightly in between your really small data services like short burst data and BGAN M2M, and so it's got a really key niche for sort of medium throughput, medium frequency of data, and it is explicitly designed for industrial IoT. So I thought it was worth just spending a couple of seconds going through what an Iridium Certus 100 device might look like. And Ben, of course, this is your baby.
Yeah, so RookREMOTE's, and it's a nice product that fits in that middle ground, but offers that range of functionality that starts to point towards, it starts to look at what the challenges of the industry are, in terms of in some cases moving from legacy technology towards an IP-based connection. So it's giving you that always-on connection, albeit a sort of a mid-data rate sort of thing. So it's not looking at high data throughput. It's looking at something for devices remotely in the field are sending regular amounts of data, but has a reliability of communications there. So you've got your Certus 100 service running behind it, that's mid-range from a satellite perspective, but also the ability to fail over or between an LTE cellular network. So you've got that true communications reliability there, depending on the environment that the device is installed into. It connects a range of different device types to it, right? So what are you going to connect into that device? How is it connected? And that goes from a RJ45 Ethernet connection through to sort of serial and digital I/O, because there are a range of legacy devices that still use those sorts of connectivity types that aren't easy to replace in different installations in different environments. So it has that sort of ability to connect in multiple things, reliability of communication on via satellite and LTE. But it also starts to introduce the elements of edge computing. So there's a processing power and memory within the device itself that allows us to be able to build applications on top of the device that help with that edge processing, right? Helps with that optimization of data before it's sent over the network. So take the data in from the monitoring devices, process it, optimize it for the network using services like MQTT, and then sending it efficiently over the network. So it's kind of a box that's flexible in its capability depending on how you want to use it. So a good example of something that can be used to ultimately make your data communications far more efficient.
So in summary, BGAN devices can be optimized to reduce your data transmission costs. So the mitigation of the BGAN data size can be achieved using the power of reporting by exception, as we've described, and it can also be achieved by implementing things like edge computing and these publish/subscribe protocols such as DMP3 or MQTT. We would absolutely urge you to make sure you're using the value-added services of your hardware airtime provider to help manage your devices and stay on top of your data usage. We've talked a lot about Ground Control's Cloud Loop service. It's very good. I'm sure it's not unique. Make sure that you're working with a provider that can give you tools like that. Not every part of the well life cycle needs the relatively high throughput of a BGAN device, so make sure you're exploring the full range of satellite connectivity options. And if your BGAN devices are reaching end of life, you might want to consider an edge computing capable device to future-proof your connectivity and lower your costs. And it can either replace, or it can actually, as Ben said, because it can connect to these legacy devices, and can extend the life of your current terminals. That's all from us today. Thank you so much for your time. Ben, have you anything further to add, or is that it from us?
That's it from us.
All right, thank you so much.